So children, we come to the last part of this heading number 5, that is law of mass action, and we are coming to the application or uses of equilibrium constant. So it has got a lot of practical utility. So it's, as a chemistry student, I think we should understand it properly. So applications or uses of equilibrium constant. Before I get into this discussion, I must remind you what I told you already, that at any given instant, concentration of products upon concentration of reactants is denoted as QC, and this is reaction quotient. Iska value will not be constant. It can be more, it can be less. It depends upon at what stage of the reaction you have found this value. But at equilibrium, when the equilibrium is achieved, reaction has proceeded, and then when the rate of forward reaction is go to rate of backward reaction, and the equilibrium is achieved, at that time the concentration of products to the concentration of reactants is denoted as Kc, that is equilibrium constant. Is that okay? I have reminded you of this beforehand because the application or uses of equilibrium constant is mainly based on the relation between QC and Kc. I'll come to that. Is it okay? Now, first and foremost thing, there are two applications we'll be doing. The first one, the prediction of extent of reaction. The first application is prediction of extent of reaction. Now, my point is this, that is, to what extent a reactant will give product or product will give you reactant. So suppose there is a reaction in which the reactants are giving you products and there is an equilibrium. So point number one, I would say, if the value of Kc is high, now you ask me high means what? That is the Kc is more than 10 raised to 3. Okay, in that case, what does it mean? That means, see, my point is the Kc is concentration of product upon concentration of reactant. So if this value is high, what does it mean? The value of product is more and value of reactant is less. That means the reaction has gone at equilibrium. That means reaction has gone more to form product, and that means the tendency of the forward reaction will be very high, and in this case you will get large amount of product, and the remaining amount of reactant will be very, very less. And in such reaction, the reaction will go to a large extent to the completion. It will not complete, but will go to a very, very large extent to completion. So when the equilibrium is achieved, you will find a huge amount of product you have got, but amount of reactant is very, very less, because tendency of reactant to form the product is very high, whereas tendency of the product to give you back the reactant is very less. And that is the reason I say the forward reaction is very high and you will get large amount of product. And it also indicates that the product is more stable. It also indicates the product is more stable as compared to the reactant. This is first point. The second point is, if the value of if the value of Kc is very low. Now you will ask me, what do you mean by very low? That is, the value of Kc is less than 10 raised to minus 3. It is even less than 10 raised to minus 3. So what does it mean? This means that at equilibrium, amount of product is very less and amount of reactant is very high. That is why this ratio is giving you in decimal 0.001 or even lesser than that. This means the tendency of forward reaction is very less and tendency of backward reaction is more. And this is an indication that the reactants are more stable than the product. तो जैसा प्रोडक्ट बनेगा तो ज़्यादा करके प्रोडक्ट रिएक्टेंट वापस दे देगा and the equilibrium will be achieved. So tendency of the forward reaction is very less, tendency of the backward reaction is more, and that is an indication that the reactants are much more stable than the product. Is it okay? And now you will ask me, if third point, if the value of Kc is between 10 raised to 3 and 10 raised to minus 3, it is intermediate. If the value of Kc is intermediate, this indicates that it is a very suitable reversible reaction, and at equilibrium you get a very good amount of concentration of products as well as reactants. That means the equilibrium concentration of both reactants and products are quite what I would say significant. Is that clear to you? So I repeat once again, if the value of Kc is between 10 raised to 3 and 10 raised to minus 3, that is intermittent, this is an indication the reaction is in a proper way. It is truly a reversible reaction, and the equilibrium concentrations of the reactants and products are quite significant. All right. So that is one thing. So from the value of Kc ज़्यादा है तो there will be more forward reaction, बहुत कम है तो more the forward reaction will be less, and is in between. So reasonable amount of reactants will give you reasonable amount of products, and there will be an equilibrium, right? So this is one aspect, and the second aspect is prediction of direction of reaction. That is second point. Second point is prediction. Point number 2. Prediction of direction of reaction. That is, you know, for a particular reaction what is the value of Kc. So at any given instant, suppose you find the ratio, so there will be Qc. If you find the value of Qc is much lesser than Kc, so this means the reaction will go more in the forward direction now, because suppose the Kc value is 100 and at an instant you find Qc value you have found is only 10. So you know it will go up to 100, then the equilibrium will be achieved, and that means you can always predict the reaction now is going to go very much in the forward direction. But if you find Qc is equal to Kc, so you say the reaction has come to a completion because the equilibrium is achieved, right? The equilibrium has been achieved, so reaction has come to a standstill, apparent standstill. Now Qc cannot be more than Kc normally, but if we make, suppose I have added more amount of product, reaction has achieved equilibrium, और फिर मैं बाहर से थोड़ा product डाल दिया, तो in that case what will happen, you will find that the product value has become higher than what it should have been, and then it has to become less. So reaction will start going in the backward direction. So if we make, that is artificially we make it by disturbing the equilibrium, make QC greater than Kc, QC greater than Kc, then the reaction will go more in the backward direction. But if QC is much lesser than Kc, the reaction will go more in the forward direction. And when QC is equal to Kc, we know the equilibrium is achieved. Is it okay with you? So that is all about the application and uses of equilibrium constant. You can always refer your textbook and get the words for your making the notes. All right, children. Thank you. Thanks a lot. God bless you.